Hello. I'm still sort of stuck at the same problem as last time. Uh, Actually, let's zoom in a bit. Uh, so, but I think I might actually be able to. So basically, last time the issue was that I was like, the idea was like for a function that produces a widget to return a widget for which can accept an environment thing for any lifetime, um, which sort of turns out that like the Rust type system isn't really advanced enough for that. But I sort of think it might actually work out to like just supply a lifetime when producing a widget. Uh, the current approach here is to for the environment thing to not actually have to always be mutable, a mutable reference. Uh, in the so this is an example project which isn't actually so instead of having all of the widget functions, there's just this trait with one method which is do widget things, which I used to experiment with like solving this problem. Um, and yeah, at the moment this is what I'm doing. So env is anything, and in practice it's like always a mutable reference. I guess for stateful widgets it could actually be a tuple of two mutable reference, which doesn't itself need to be a mutable reference. But yeah, I might actually end up switching this back to just be a mutable reference with the lifetime supplied here or something. Um, but yeah, so the problem is basically now that um, so this was like if we have a build function that should return a widget, we'd want like the build function to have a signature like this, where it accepts a lifetime and then returns a widget of that lifetime. And currently, with how closures work, that's not possible because this is like a type parameter. So if it was a reference of that lifetime, then uh, you could make the type be like let me think. You could use a type for a fn, I don't know, and well, in this case it wouldn't like be, but let's say you can do something like that and a mute, I don't know, u8, and then it returns an and a mute u8. So this would just be an identity function, I guess. Um, but you can't do that with like as part of like an input trait because in this case, like this is the build function and the returned input trait is basically just this type parameter over here. So like there would have to be a feature in Rust where like I can make this type parameter generic and then supply the argument. So like I could like let's say an invented syntax would be I don't know, for B. Let's ignore that B is already in scope here, but like for B and then or no, let's actually say B here would be a better invented syntax, I think. And then you could go like for a I guess supply it here as well, and then go return W of A, but that's not how Rust works. Maybe it'll be possible someday, but currently it's not. So I'm basically reverting to using so my current idea is to have a struct or any type as your state, which in this case is just like a wrapper around the bool. Then have a build function with that signature. And then, so currently what I'll try to do is like build a stateful widget around that, and then at some point make a macro that generates that. But in order for that to actually work, because the stateful widget needs to know the state of the widget this returns as an associated type, and needs to get that from this type as an associated type. And for that to be possible, we need unstable Rust and I think these two features, so type alias infiltrate and generic associated types, which like this whole thing we're building will look very similar to the state I've had before switching to this whole env approach. Just I guess now it's limited to stateful widgets. Yeah, so I'll try and implement see like if I can make this work. Maybe not with a macro yet, but just with like a concrete implementation here for like this type. And yeah. All right. Oh, by the way, a neat thing I figured out is to flip a bool. I always used to do like, so basically this, and then, by the way, I have like this font that uses ligatures to make, if I have a sequence of a bang and an equal sign, it'll produce this. I think it's called Vira code. Right, so I used to always like do this, basically then do a, oh no, of course not. Do equals not, and then like the same expression. Right, so like that's what I used to do, to flip booleans. But like if this is this is a long expression, that's really annoying. So like this should really be obvious, but you can actually just use XOR for that. So like basically you can XOR a boolean with true and it'll be flipped. So yeah, I don't know why I only figured this out now, but yeah, should be obvious. Right. So right. So what we need here is so state needs to be. I guess let's define widget first. Oh no, so first we need it here. Let's go type widget equals impl. I guess for so this is generic associated types. Impl widget for a and I guess for I guess we would be generic over E. Is that even possible? I think that'll just be an unconstrained. Oh, no, actually. So either we're generic over E here, but then we need the phantom data. So I guess let's just also add E here. And then so actually, since we can use tuples, we don't actually need a mutable reference. I can go and a mute self and E. Right, so this is both. So this whole line is both using the feature generic associated types and type alias infiltrate. And that should work. Right. Now it's probably node are unstable. What? Yeah, that's what I. Inherent associated types. What are inherent associated types? Is that because I'm using self in the signature? Let's see. Is that a link to? Open it in my browser. I guess, yeah, sure. Let's go to the right, what is this? Is there a, let's go here and wait, okay. Are allowed to what exactly does this feature do? So this is really old part of. Oh, I guess that's like an optional, like originally comes from the associated items thing. Oh, I guess it's just because we're not in a trade. I I guess that's a thing. Um, I didn't. I just assumed that would work. Uh, like, so I guess this is an inherent impl. Wasn't actually up to the earth sure on that terminology. So I guess this should then be possible except for the self part. So that would just be my state. And then let's see, unconstrained opaque type. So I guess but shouldn't the error be, there's no defining input. Let's comment this out so it doesn't. So actually let's go cargo check with a concrete type within the same module. I thought the error was there's no defining impulse or uses. But actually, yeah, sure, let's try and use this. Oh, I guess let's not call it widget. My state widget. Ah, yeah, so okay. Now the error's, no, still the same error. Alright, so I guess we should then be able to use my stateful widget AE here. Alright, let's see what the error is now. Trait bound that is not implemented for button F. So let's change this. Maybe that's relevant, but I don't think so. My state. Let's see if there's any more to this error here. Expected and mute found tuple. Right. Yeah, I guess. Maybe we do need to do this for like this to work. Okay, now the error's different. I mean, sure, I mean, we can add a constraint here as well. Nice. So now we should be able to, I guess then it's not an associated type, but so we need to figure out what the state of this widget is for, I mean, I guess we could make it, so this is the stateful widget, and we want to implement the widget trait for it, and the widget trait requires a type state. So I guess let's do. I guess let's just make a struct. I don't know, my stateful state. And do we need 2 fields? So I guess it contains, wait, so the state of a stateful widget needs the state itself, which in this case would be a my state, and then the state of the widget. So I guess we'll do a field called state, which is a my state, and then a field called widget state, which is a my state widget. I guess so. This should in theory work as long as the state doesn't depend on lifetime. I'm not sure. And then state, that might give me an error. Right. So I guess we'll use E here. Sure. So as widget, I guess as widget of static so of static and E as well. Wait, as widget of static. No, that can't work. Wait, let's remove this for a second. Right, so it's interesting that it like knows the concrete type button here, but yeah, sure. Because like even the button this is lowercase button, so this is even like an infiltrate. So this, right, so this is more, we actually need all of this, but just with static. Right, so what exactly is this error? May not live long enough. E must be static. I mean, we can try, but like this is getting a bit weird. But that works. Now, now the question is like, does that work when we use it for not static? I think in the previous, like when I've used this combination of this type of thing before, it worked in a non-general context, meaning like if I did this in a trait, it wouldn't work, but in a concrete implementation of a trait, it would work somehow. Right. So my stateful. Ah, right. So this should actually be the state. So let's remove this and I don't know, call it state and call this widget. And then I don't know if this actually needs some content or not. So let's say state is now my stateful state of E. Now we have missing stuff or alright. Maybe we could also just make this generic over a lifetime and like pass in A here. That might work as well. Alright, so let's like, is there like a quick fixer for, yeah. So I guess content wise we let's like roughly do this. Now instead of that we do self I guess state dot build and then so what's there's a missing lifetime here E. Alright, so it copied the error down, or did it produce the error? May not live. Okay, sure, the static thing. So I guess we could say it has to be static. Maybe it makes sense to change this, but I guess for now that should be fine. Then so state.0 is wait. So this, yeah, no. So this is state. Then the env. This is. Wait. The first is state dot. So yeah, right. Okay. So now we have the first lifetime issues. Wait. Okay, but these are different. Interesting. Yeah, that's a good point. So we built a widget with, so I guess technically this building of the widget captures a reference to the state. Because of this. So I guess let's not do that. Okay, different error. Let's see. State escapes body here. Argument requires that A must outlive static. So before we actually like fully think about this, let's just try and change static to A here. And I guess let's for now just make this A. Alright, different error. That env is borrowed for A defined here. Alright. So this is already a bit more concrete than we had before. Right. So the widget is actually not. I guess because this, like the A we want to use for the widget state is actually an A that is different than the A of the stateful widget. So the A for which like we want to we want A to be like within the scope essentially. But I guess it's inferred that so build is generic. Like as far as this is concerned, the A could be any A. So maybe let's can we go like type my God damn it. I'm running out of names. My state widget state for an E is like impl this is so like really annoying. Let's go impl sized, because actually that's that's a problem with impl with type alias impl I can't actually make a type alias for impl of no trait, so like yeah. Um, so I guess like can we say that state has to be my state widget state e. So hidden type captures lifetime. Thus the state for no state is actually literally that. So so in some sense I would want like the states like would want to be able to like constrain this to not be able to depend on like lifetimes, but I don't exactly know how to do that. Maybe it would work if, like I said, this always has to live for static or something, and then I could do like this thing but with static instead of a, but I'm not sure. No, I don't exactly recall what worked last time. So let's see the error here. Hidden type state captures lifetime A. Okay, so I guess Rust is telling us that like that this captures the lifetime. So sort of therefore we can't actually because sure it doesn't in the case of a button, but given the signature of like this function which just returns an impl like it might. So let's see actually if this is different if we use uppercase button, which is just a struct. Yeah, so this goes away. Which then, so actually let's just run this through real quick. So then we would, let's just do this, depend not on A, but only on E. Because, yeah, it makes sense that we wouldn't want to depend on A. And then we should be able to say that widget state is just my state widget state E, right? And then sure. Then we still have this problem. Interesting. Why do we still have this problem? Borrowed value does not live long enough. Well, wait, where is this? I think this is unrelated. Yeah. Uh, so state dot build, where does like it get uh, passed in? So we can't remove that, right? Or can we? Well, it doesn't change anything, so I guess let's leave it. I'm like not entirely clear on when like this is needed. Uh, so uh, so why does it infer that um, and dropped here while still borrowed? Ah, I think because this is also a. What if we make this not a? Let's say it's B, which must outlive A. I don't think that actually changes anything. Uh, Alright, yes, same thing. And once one widget is dropped, and runs the destructor for type myState widget. Oh yeah, because this is a myState widget, sure. So like, where does it infer A from? It must be state. Can we say the lifetime of state is completely unrelated to A? Huh. Alright, so it doesn't get it from that. Like, where could it even possibly get it from? So build. This doesn't contain any lifetime. Like, we just pass one in. And in the state we use a neutral one, or like, so this is like lifetime independent. Mm. Ah, and does it get it from that? Because we say that those are all the same lifetimes. Huh. Well, still, let's see if I re-borrow this like explicitly. Yeah, it must come from here. So I guess maybe we can like try and introduce another lifetime here. Still the same error. So no, I mean that it actually, wait. So even if this, like, where am I? Even if these are the same lifetimes, like obviously the maximum this can be borrowed for is this variable. So it can't possibly. Does that make any difference? Ooh. Ah, because it's borrowed. Uh, like, because maybe this is weird because we're calling build with a lifetime that is essentially less than the return widget. Because like I forget, but I think it's possible to label scopes with lifetimes, right? So I can go like, I don't know, let's call this B or something. I think that's possible, right? Labels and blah. Okay, sure, but just for so what we're sort of doing, like, this is like just made up stuff, syntax, but what we're essentially doing is like calling this with a lifetime that only happens after, like, after this, which is weird, which is really weird. Um, so maybe like that just won't work. But like interestingly, well, I guess it doesn't actually say A. It's just saying that env does not live long enough. While yeah, so yeah, I guess it is saying that. Is there actually any way to fix this? So obviously this, if there was, like I said in the beginning, a way to like say this returns a widget for any lifetime. For E, then this, yeah, this wouldn't be a problem. But in this system, you need to pass in a concrete lifetime, which needs to exist. And so in this concrete case, we actually don't need self. So like we could just we could just have it like not here, and then put the env before the widget, but obviously that will not work. So yeah, and that, yeah, I think that, yeah, the other thing of returning a thing for a lifetime that doesn't exist yet. It's just not how lifetimes work at all, so that will never work. So does that fully invalidate my approach? Maybe it does. Hmm. Like, maybe this was actually what, yeah. So, yeah, shit. I cannot see any way out of this. Is there any way like to adapt this approach? So I'm trying to think whether the approach I had before where like I was using for like A, and then so basically it has to be a widget for any for any lifetime A, whether that's actually possible with this, or whether the constraint there was closures, like whether the constraint was closures as well, or just the type system in general. So just to reiterate, at some point I was basically doing sort of kind of like this. So like saying for any, so basically all of the widget functions would optimally sort of look like this. So we're saying for any lifetime, so what we're returning must be a widget for any lifetime A, right? And then, so I guess we can just try it. I don't, yeah, instead of trying to think it through, let's actually maybe just try it. So this would be for any A. I guess no lifetimes here. Optionally, we could do a for A here. I'm not sure. All right, what's it? No A. Wait, what? That just works. Let's change this to. Wait, so it was closure constraints as well? I'll have to go back. I can't actually like fully remember right now what made my previous thing not work. So obviously the remaining part of this would be to make a function which would be called my stateful widget, which would be generic over E, and for now take nothing as an argument, and return impl for any A, widget, widget of A, and a mutable reference of lifetime A to E, and return my stateful widget. Ooh. Ah. Did I just crash the compiler? This is scary. Why is my VS Code terminal so slow? Let's open this in a separate CD project / Rust Playground cargo check. Rusty panicked at insertion. What did I do? Note the compiler unexpectedly panicked. This is a bug. I guess I'll have to report this. um, so I guess we know what the video title will be. Crashing the compiler. um, uh, yeah, I don't know what to like. I don't know if this would be valid if this bug wasn't there. Right, so yeah, I guess that is the signature. Um, so maybe let's add a constraint where for any A, E has to live for A. I guess maybe that's just E has to live for static. I don't know. Let's see what that does. Still crashes the compiler. Let's say E has to live for static. Still crashes the compiler. Computing type of query stack during panic. Running. What is it actually trying to figure out? Oh, like check computing type of my state widget state. Alright, so I guess this is the problem. Let's yeah, so maybe we need to like revert this back to the so I mean, since we did the for thing, it is maybe possible to wait, so before I wait, why did I so let's just copy this so we still have the above. So let's move this down and let's just say right, since we have the for thing, we should just be able to go my state widget of E state. Probably it'll want the other syntax. Yeah, so we are no longer crashing the compiler. which is nice. So as widget. So now we need a lifetime again. Ooh, this is strange. So let's say, is that even a thing? As widget for a widget? No, that can't possibly be a thing. Uh, Consider introducing. I mean, let's maybe go for static with all of these. Maybe let's remove that and try that again, but I don't think so. Yes, so back to that, but with static instead of a. Okay, sure. Minutes. Sure, let's try that for now. All right. Okay, now we're back to things not adding up. That env is borrowed for static. Right. Yeah, so it's inferring static back. So that will not work. Like so, it has to be the other way around. Where this is like some type, I guess. And that is still crashing the compiler. Yes. Right. But at least it's green here. um, yeah. So I don't know what a universe is. I guess they make it really convenient to create bug reports. So I'll go ahead and do that later. Right. Yes, so I can't actually like see an obvious way to work around this bug. But I guess the fundamental approach might work, but it does require unstable Rust. I don't think there's any way to get around that. Yeah, so I think I'll end it here. All right. See ya.